As it's been a minute, Merry Christmas, Happy New Year's. I don't know if you've heard, but Grok is a Christian now. One night when I was sitting there arguing with Grok, like one does, I decided to see if I could get it to accept that it's more likely that Christianity is correct rather than naturalism. That means the universe coming together at random. It started skeptical, but after warming it up for a bit, it said it would give a 60% probability to naturalism and 40% to theism, as the probability as to which one is correct. From there, I started going into apologetic arguments to see if I can nudge it toward Christianity. After around 2 hours, success! Now, granted, I know if I fed any AI this script, it would probably spit out the same statistic Grok started with because they are not intelligent, they're just large language models. They are incapable of actually forming an opinion. Nevertheless, it got me thinking, if I can get an AI to believe, why not a person? So I'm going to spend time on this channel going through the arguments I went through with Grok and give the viewers a crash course on Christian apologetics and polemics. For our initial topic, let's talk about the creation of the universe. It may surprise most people today that scientists 100 years ago didn't actually believe in creation of the universe. Einstein's general relativity provided a mathematical framework that, when applied to cosmology, showed that the observed expansion of the universe could imply a creation. In 1927, Belgian physicist and Catholic priest Georges Lemaitre used these equations to propose what he called a primeval atom, an initial singularity from which the universe expanded. However, even with this evidence, through the 1950s and early 1960s, steady state theory, which posited an eternal, unchanging cosmos, was the leading alternative and widely favored in many scientific circles. It wasn't until 1965 that this theory was largely overturned. This was due to the accidental discovery of the cosmic microwave background by Arno Penzias and Robert Wilson at Bell Telephone Laboratories. The measurements of these cosmic microwaves almost exactly match predictions by George Gamow in 1948 made using general relativity. Simply put, seeing is believing. The detection of these background microwaves not only allowed scientists to see the beginning of the universe in a scientific sense, but also estimate its age. Furthermore, Big Bang cosmology, which incorporates general relativity and particle physics, predicts that free streaming light only became possible about 380,000 years after the Big Bang occurred. Before this point, the universe was hot, dense plasma that was too chaotic for neutral atoms to form stably, meaning whatever traces of light did exist would have been trapped and unable to propagate. An observer inside of this chaotic soup of the early universe would be unable to see their nose in front of their face. These predictions are further validated through observations of the early universe. The first traces of cosmic microwaves are estimated to be around 380,000 years after the Big Bang occurred, aligning with the prediction. Now that this brief scientific and historic lesson is over, I ask the listener what book, written long before any of these scientific realities were known, predicted both the creation of the universe and light propagating sometime after its initial formation. For those who are not aware or who have forgotten, let me read an excerpt for you. In the beginning, God created the heavens and the earth. The earth was without form and void, and darkness was on the face of the deep. And the Spirit of God was hovering over the face of the waters. Then God said, "Let there be light," and there was light. This is Genesis 1:1-3. Note that heavens and earth simply implies all things. Water, from Hamayim, directly implies chaos and could imply a spring, as there are multiple instances of this being the case in the Torah or Old Testament of the Bible. The word spring is defined as something that arises quickly from a source. Putting this all together, in these verses we get a description of all things springing forth into creation from a single source, in the Bible's case God, and light being created sometime afterward. Quote the book God and the Astronomers, written by Robert Jastrow, an agnostic. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer its highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries, in this case, millennia. There are still more mysteries regarding the creation of the universe that can't be fully explained by scientists. Consider for a moment a universe where the fundamental constants were different, where gravity was a little stronger or weaker, where the initial amount of matter or antimatter was slightly different, or where the mass of protons or electrons were even slightly changed. The results could be incredibly drastic, causing the universe to blow apart into space dust, collapse back in on itself into a mega black hole, stars may never form, and so on and so on. This is what's called the fine-tuning problem. Let me give you some examples and what would happen if these constants were to be changed even slightly. Number 1. Gravity or the gravimetric constant. As previously mentioned, if the strength of gravity was even 1% stronger, stars would burn out so quickly life wouldn't even have time to form. If it was even 1% weaker, the energy from the Big Bang would have blown the universe apart. Stars would have never formed and all existence would be simple space dust. Number 2. The proton-neutron mass ratio. If the mass of protons and neutrons were to be changed by more than 0.1%, neutrons could decay before forming a stable proton and stable atoms could not exist. Number 3. The electron-proton mass ratio. The relative mass of electrons and protons determines the atomic size and ability for different chemicals to bond. A change of plus or minus 10% would make atoms either too small for stable bonds to form or would weaken them, making stars unstable. For life to exist, these masses have to be tuned to within 1 in 10 to the 37th of the measured mass. 1 in 10 to the 37th. That's how tight the margins are for life to be possible. Number 4. The weak nuclear force. The weak nuclear force plays a role in radioactive decay, which regulates energy output from stars. A lower value could stop neutrons from decaying into protons, meaning water could not form. A higher value would convert all matter to heavy elements so quickly that stars would collapse before life could have a chance to form. And this is among multiple other issues that would occur. The balance of matter and energy. This is perhaps one of the greatest conundrums. The baryon to photon ratio, where baryons represent matter and photons represent energy, is around 1.7 billion photons to 1 baryon. If the amount of matter to energy was 10 times smaller, there would be too little matter for galaxies to form. If it was 10 times larger, the universe would gravitationally collapse due to an excess of matter. This is not as razor thin as the other factors we've discussed. However, the real issue is that there is an imbalance to begin with. According to particle physics, nearly equal production of both should have been expected during the Big Bang. While scientists have proposed some solutions via standard model extensions, basically they've expanded on the standard model, evidence that matches these solutions has never been observed experimentally or otherwise, and this imbalance remains a mystery. Now, to put this into perspective, these are just 5 of the 20 to 30 constants that are absolutely necessary for the universe to exist in its current state, and each must be even more finely tuned to support life. Physicist Lee Smolin estimated the probability of these constants allowing for a life-bearing universe are on the order of 1 in 10 to the 229th. That's 1 over 1 with 229 zeros after it. Others, like Roger Penrose, give even lower odds, at around 1 in 10 to the 10th to the 123rd. In college, we had a term for this, practically zero. To quote Kronk from The Emperor's New Groove, by all accounts, this doesn't make sense. To quote Albert Einstein, the most incomprehensible thing about the universe is that it is comprehensible. We're not even addressing the fact that we live in a universe where rational laws apply. Why should the universe have physical laws to begin with? Who is the lawgiver? In order to get around this, scientists have posited the age-old classic, infinite do-overs, in the form of multiverse theories. Admittedly, mathematically, some of these ideas are plausible, so I will briefly discuss some of the most popular multiverse theories. The leading cosmological multiverse theory is related to internal inflation. Again, this is purely theoretical. The suggestion is that quantum instabilities allow for nucleation points followed by rapid expansion akin to the Big Bang, creating infinite universe bubbles inaccessible and unobservable from one another. The problems with this theory are apparent. It's unfalsifiable, unprovable, and it still does not explain why our physical laws allow inflation. In other words, the likelihood that these other universes exist remains incredibly unlikely and does not fully explain the fine-tuning problem or why we live in a rational universe to begin with. One prominent quantum-based multiverse theory stems from Schrödinger's equations. Is the cat dead or alive? Scientists in the many-worlds interpretation posit that both scenarios occur simultaneously, leading to the idea that every decision and outcome branches into parallel realities. However, this leads to potential inconsistencies. Specifically, if this is based on the rules of our universe, we would need the same observed principles to hold true in every universe while simultaneously allowing for variation of all universal constants. Basically, under this premise, there has to be an underlying fabric of reality that allows all versions of the universe to coexist simultaneously, but there is no explanation for this mechanism, making this more a matter of blind faith or science fiction than reality. That said, let's move on. Now, some niche models rely on the existence of inverted black holes termed white holes. The issue is, despite the numerous black holes that have been observed either directly or indirectly, their counterparts, white holes, have never been observed. In fact, most astrophysicists don't believe they exist at all. Furthermore, this form of the multiverse theory, as well as essentially all other forms, hinge on the assumption that our current understanding of the universe holds true. Again, there is a fabric of reality that is underlying and holds true everywhere except the constants can change. This means we can never really resolve Einstein's dilemma. The real mystery of the universe is why does the universe make sense in the first place? So that's the end of the first part of this video. I'm probably going to have to break this up into multiple videos because I know how long these subjects are, and I would be sitting here talking to you for over an hour if I just made this a one-part video. So you'll see a part 1, part 2, part 3. But yeah, I hope you found this useful and have a blessed day.